between all the other engineers, and they take care of all the complex systems involved, and even a slightest mistake here can prove deadly. So they have to be really careful. So systems engineering basically focuses on on creating, validating, and testing the complex systems involved, and it involves a coding language called SysML coding language, and they introduced the second version on the July 2025, which has become increasingly useful. But at the same time, it is much more it's just much more difficult to learn, and it's not organized at all. The old system engineering processes, the diagrams, all the BDD, the IBD diagrams, and the requirements, the compliance and verifications have been scattered all the way, and it's not been organized into a single file structure for them to learn. And also, the code at the same time has proven to be a very daunting task for all system engineers. So what we have here in Spectra is basically a cursor for systems engineers, specially designed for them. Where you have, for example, you're testing a drone, and you have the drone structure here. So you have a block diagram, a block definition diagram, which basically tells you the hierarchy of the overall structure. So we have the vehicle definition here, and what parts exist behind it. So we have the five nested parts. You have the propulsion system definition, and you have the navigation system definition, you have the payload system definition, you have the power system definition, you have the communication system definition, and you have the different ports connected to it. So you can change anything through just a small chat here. And once this is done, and you have the IBD. The IBD is the internal block diagram. The IBD says basically, the IBD says tells about the internal structure and how different parts are connected to each other through different connection types. For example, you have the propulsion system, and it's connected through the power to a communication system. And for example, and you have this is a positional data here, and this is through telemetry, and this is to overall video out payload. So this is how the overall drone system is connected to. And for example, if you want to talk about the visualization of how the system will be and how they're connected to, we have a 3D structure, a 3D visualization structure, telling and helping us understand the overall subsystems involved in creating a drone. So you have the vehicle frame, the vehicle definition here, and you have the propulsion system, the four motors available, and you have the GPS or navigation system, and you have a camera or a payload system down. So exactly what we discussed, and what was then the block diagrams, the Intel block diagram. So this is the overall requirements. So what the requirements that the system needs, and what has to be covered, which records and traces, and it tells us how whether the requirement satisfies the current like the current data, and what we have to do more, and how much has it covered. So that's another important part. And this is the state machine diagram, and this is the sequence diagram. So once this is done, and then you have the requirements once again, as we discussed. So so there's total 8 requirements needed. One verified, we have 2 issues that is automatically configured here. So and then comes the compliance. So the compliance center is basically tracks the certification status and generates required documentation based on that. So if you want to create a document based on that, you can just mention here and create a document based on the compliance center. So it's as simple as that. You don't need to manually do anything, and it covers everything. So if you have identified a gap, and then you can exploit a gap report. So it makes the job much more simple. And then you have the verification dashboard. The verification dashboard is basically tells you the overall what the system is, and how how the system acts and everything. So the overall verification dashboard here. So it tracks test cases, it verifies the status and analyzes it. So for example, okay, if I want to change the subsystem, I want to change the subsystem. I'm creating a collision avoidance subsystem with a different radar and lidar sensors, and I'm inserting it here. And you see the SysML beta code. The basic definition, the diagrams are also represented using the SysML code. So you need to change the SysML code to change anything based on the diagrams. So it checks for it, and if you want to change something, so it has given you a code based on that, because it has already used the code. So now we have to apply this to the model. You want to apply this to the model, and it automatically goes and changes to it, so you get a different version of it, right? So that's how. So you have a collision model that has been placed, and have different kind of wide collision models, and you can integrate it wherever you want. So there's the radar sensor definition, and that is the lidar sensor definition and collision process definition. So this can be integrated wherever you want. So if you want to integrate it here, integrate it here. So that's how it works. So it's basically